Hello, this is Minder Chen. I'm Professor of Management Information System at CSU Channel Island. We're going to talk about data analytics in this lecture. Data analytics sometimes has been referred to as data science, business analytics. There are some differences, but we're going to use the term interchangeably. Let's first look at the outline of this lecture. We'll go back to the history and talk about the traditional so-called decision support system, which is kind of old-fashioned way of referring to how we analyze data and help us to make a better decision. And DSS, as we call it, evolved into business intelligence, and particularly using a variation of the database technology, which we call it data warehouse. And then we move on to AI and generative AI, and in particular machine learning, to help us to recognizing pattern and making prediction, and that's where the machine learning come in. It's a subset of artificial intelligence. And then in conclusion, we're going to kind of review the data analytic life cycle, so we get a broader overview, in particular from a business perspective. So let's get started. Herbert Simon, who's very well known in various fields in economics and in decision making in artificial intelligence, came up with kind of a four-phase model of decision making. The first one, as he referred to, is called intelligence, gathering information, identify problem, and which may involve environmental scanning, gathering internal and particular external data, and such that we can identify the situation, and the situation leads to certain issue that we need to address and analyze in order to make a decision. The second phase is design phase, come up with different alternative in terms of how we should deal with the problem. This once again involve gathering the data and also devise certain approach in problem solving. And once we have various alternatives, then we are ready to move to the third phase, which is making choice. We will look at the alternatives in front of us, and based on certain criteria, which is probably has been predefined, and then evaluate those alternatives, decided which one to choose. And Simon particularly emphasized that it's impossible to exhaust all the possible alternatives. So a lot of time, we would just choose something that's to our satisfaction. He sometimes referred to as satisficing, kind of good enough is enough, okay? Because further research may involve higher costs, which may not be able to justify. Okay, and the last two is to implement your choice, which involve the actual allocation of resources, implementation of the new systems, and also measure the kind of performance metrics of the decision we have made, and which will provide feedback for us to decide whether we should go back and redesign our solution. So if we put the four phases in sequence, as we can see on the left-hand side, intelligence, design, choices, and implementation. Our traditional management information system will give us basic information to help us to recognizing the problem and help us to define the problem. And certainly there's a lot of human involvement. And also MIS is part of the implementation at the end. The MS, management science, operation research, decision science, whatever you want to call it, which certainly involves statistics, is involved in design various alternative building model. Here the model is not data model. The model is decision-making model, machine learning model, and then we would evaluate, for instance, which model give us the best prediction and decided which model we should use to help us to make better decision. On the right-hand side is decision support system, which include database or data management system, and certainly include the so-called DBMS and other data-related system. The second one, we call it model-based, which means the various decision model, machine learning model that we may use. I added an extra component we call it knowledge base, which could be part of the so-called traditional expert system, the new machine learning model, which could be part of the knowledge base. And the last component is the user interface, is how we interact with the user such that the user can use the decision support system to help them to make decisions. Let's look at a little bit detail in terms of the data side, the decision model side, and the user interface side corresponding to data analytic using this decision science, decision support system framework. The data for decision making may come in as a flat file, an Excel file. And the data certainly can come from our database, which we have discussed before. In database, we can do a little of analysis like filtering, sorting, joining data from multiple tables, calculate aggregate function like sum, average, counting how many records. And we can even create summarized query using group by, so we can analyze different categorical variable, different groups, and make some comparison. And another level up is use data in the so-called data warehouse, which we will discuss a little bit later. A data warehouse is specifically a data storage and organizing software which collect data in a way that's almost ready for us to use in decision making, in data analytic. There's another thing called NoSQL, which is big data. Certainly that's part of the data solution on the left-hand side. On the right-hand side, in terms of the model, decision model, machine learning model, it could be basic descriptive model, descriptive analysis, descriptive statistic, and inferential statistic doing hypothesis testing. Or if you use Excel, we have something called what-if analysis, goal-seeking, scenario manager, and we can also use linear regression to create predictive model. If it's time series data, we can certainly do forecasting. And the predictive model allow us to optimize the resource that we have. And certainly AI, in particular machine learning and deep learning, can be used. And that should be considered part of the so-called model base. On the UI side, it's about interacting with the user, but also presenting the analytical result through data visualization in table format, pivot table, various charting tool, business graph, interactive digital dashboard, and the soft skill of storytelling with your data and certain data analyzed by the model that we have. Let's look at a little bit of what we call data warehouse, which is a classic solution for putting data in one place to help us to make decisions. And we do have data from our online transaction processing system, which could be stored in various databases. And certainly some of those data source could be flat file. We go through a process called ETL, extract, transform, and loading. We load the data into the data warehouse, and which is almost like a centralized storage place to store the data. When some unit in your organization need to use the data, sometimes we will take a subset from our data warehouse. We call it data mart. And then we allow the user to use various analytical tool, to retrieve data from either the data warehouse or the data mart and put it in the so-called multi-dimensional online analytical processing cube. The cube is kind of a visual model, at least three-dimensional, but it's really multi-dimensional data model, which allowed us to look at various dimensions of our data and analyze it. We can use query tool, reporting tools, analytical tool, front-end analytical tools such as Excel is the classic one, Tableau, Power BI, also popular tool in recent years. If we go back to the basic, here I have a kind of a statement, okay? Like the manager is saying that we need a monthly sales, okay? But we don't stop there. We need monthly sales by customer, product, and store, which means we need to group the sales data by customer, by product, by store. And by the way, when we say monthly sale, we are actually grouping our sales data by the time dimension on monthly basis. Okay, and if you remember in database, we have something called group by. So we can group by customer, we can group by product, we can group by store, and we can group by month. And the month, customer, product, and store is what we call dimension, different perspective in looking at the data. In the sales data is the measure. It's how potentially we measure our performance, the sales performance. Okay, so we have two terms, important term, dimension and measure. Okay, the measure help us to measure some performance, like sales performance. The dimension are looking at what are the factors driving such performance. If performance go down. We want to know why. It could be because of certain product. It could be for certain store's performance, and that's the dimension that we need to look at, which help us to understand what's happening. When we look at the data, sometimes we will compare the data. For instance, like real estate sales data, compared the sales data with previous month, and sometimes we do compare the sales data to the same month's previous year because there are seasonal factors. So comparing to the previous year of the same month sometimes make better sense. But certainly we can look at the seasonality of our data, particularly in forecasting. So this is a little conceptual, but I think it's very important for you to understand a lot of things that we're going to talk about down the road. And so when we look at our data, one angle to look at it is to see whether that data item, okay, in our table, in our spreadsheet, is that a measuring performance, like sales, like cost, like account balance, number of units sold. They're typically numerical data for sure. There's also attribute or column in our data set we refer to as dimension. Okay. They are an attribute. They're usually discrete value or categorical variable. They're usually they're not the performance measure, but they are the driver driving those performance. And we group those drivers in different dimensions, which we'll discuss. Let's look at a simplified data warehouses schema or internal design of its structure. We have sales data, we call it facts table, contain, let's just say, sales, which is in dollar amount, could be number of units sold. It's stored here. However, to describe a particular entry of a sales, it could be through which promotion, which store, and what product has been sold, and then when it was sold. So if we really look at a particular entry in the sales facts table, you find out to describe, let's say, the dollar sale. It's like when it was sold, what product we're selling, and is any promotion associated with the sales, and where was the product sold. Okay. That helps us eventually to analyze the data. When we look at particular various dimension, like the time dimension, we can sometimes find something we call a hierarchy. For instance, in time we have year, and under year we can divide it into 4 quarters, and each quarter has 3 months. So that forms a hierarchy. Okay, from the top, year to quarter to month. We can find, other than the time dimension, we can find other dimension. Like, for instance, this is, we can call it location. It's Eastern Hemisphere, Western Hemisphere, and then we can divide, like the Western Hemisphere can be North America and South America. And then this is just one of the dimension. Look at the time, look at location, look at, for instance, the transportation mechanism in terms of the transportation route. And that's how we can kind of analyze the specific data in the cell in this kind of cube is described through various dimensions. This is a hierarchy that we mentioned earlier in a product table. The product, if you look at this table, we have department. Like if you go to a grocery store, they're selling grocery for sure, but they also sell some household items. So there are mainly two departments. And certainly you can say, oh, meat department is another department. Depends how you classify it. And under each department, let's say grocery department, we have something called category. So we have the food category, we have the drink category, and we can go further down. We can have subcategory, frozen food, and I wouldn't call candy food, but it's considered food here. And then we can have brand under subcategory, okay, different brand, and then down to specific products, SKU number if you want to use SKU. So that's a typical hierarchy in just one table, and this table we usually refer as a dimension table. Okay. So why that hierarchy in a dimension is useful? Because it allowed us to follow that hierarchy to go up and down. We can drill down. When we go down to the hierarchy, we can look at the aggregated data by year, and then we can drill down to the quarter, and then we can further drill down to the month. We can certainly also roll up, have a highly aggregated information. We usually, as a manager, we look at the more highly aggregated data first, but you may want to provide the drill down capability for them to look at the detailed information. Okay. So the performance measure, like sales data, can tell us why. Okay, we made $2 million sales. That's just what? Is it a good number? Well, you have to compare to previous month's sales, the same month sale last year, to kind of get an idea whether that's a good performance. However, let's assume performance is really good. You want to know why. This is where the performance driver will come in. Is it because certain store? Is it because certain channel? Is it because of certain product category are doing well? And so we would do different slicing and dicing to get to the bottom of it. If we use the product table, we can analyze the data using, for instance, Excel pivot table. If you haven't had a chance to use pivot table, do go and play with it. It's a very powerful, useful kind of analytical tool. It's right in Excel, which you can use. And so when you look at an Excel table, let's say has all your sales information and then various dimension related attribute, like for instance where it was sold, which state it was sold, which city it was sold, and also product information. And we can analyze the sales data based on the product dimension, and then the location dimension. Then we can get this so-called pivot table. The information can be aggregated. For instance, highly aggregated, like at the grocery level, and then we can drill down and look at the drink and the food, and look at the breakdown of the sales data, and we can further cross-reference to the location dimension. Is it for particular state or particular city in the state, and look at the information. Okay. This is how you can design your pivot table, putting certain dimensional attribute in the column or row, the measure, which is numerical data in your original table or data set, and you would bring that into your so-called value field, such as the dollar sale would be a good value to analyze, but you can analyze it through various dimension putting in the row or the column. Let's move on. Machine learning come along, which allowed us to provide data to machine learning model, and the machine learning model will kind of find pattern and to help us to perform prediction classification type of the work. Okay, a classic and common approach in machine learning is what we call supervised learning, which will give kind of data that, for instance, a picture of dog and cat, and we want to recognize whether there's a dog or cat in the image. When we provide the machine learning model the image, we also want to label that. Okay, we call it label. We say, is there a dog in this photo? Okay, if it is, then we label it accordingly. So basically, we're actually have data looking at a problem or a picture. In this case, we have label that we label the object in the image. Okay, the label is considered like the solution, the answer we want. So as long as we can have this kind of photo, and whether it's a dog or cat as a label, we can train the machine learning model to recognize a new picture and tell us whether there's a dog or cat in it. And so the machine learning algorithm basically is try to find a function. It could be a linear regression function in prediction. It could be a deep learning algorithm, okay, which can do computer vision, image recognition. And so basically we're looking at the parameter of the function, which can help us to map the input, which is x to y. The input in this case would be simply just the images, okay? And the y is actually the proper label, is a dog, cat, or other object. This is a little bit complicated, but once you get used to it, if you study machine learning, you find out this is the standard process. And we follow a similar process in data analytic in the broader sense, but this is more specifically geared towards machine learning. The first step, you have to look at what data will be needed, okay, to train this machine learning model. You will acquire the data, you will clean and prepare the data to be ready to be used by the machine learning model. And for machine learning particularly, we would split the data into testing data, which usually is 20%, and the training data, which is 80% of your original data set that has been cleaned up. We use the training data to train the model. Okay, a training model sounds complicated. It is complicated, but if you're using a machine learning package like scikit-learn, you just call a machine learning model and just say fit, which is train the model for me based on the training data provided. And after the training, you need to evaluate the performance metrics of the model to see whether they are how good they are in making prediction or in classifying the object. Okay, but how do we evaluate that? We would use the test data, which has not been used for training, to evaluate the performance. If the performance is good enough, then we're ready to deploy the model. Okay, and once the model deploy, when the new data come in, we can apply the model and then make prediction, classification, making recommendation. Okay, so that's a very typical machine learning kind of process that we follow. In terms of data analytic, there are 4 types of analytic kind of approach, from simple to complex. The descriptive analytic look at what happened, okay, historical data, and look at just what happened up to this point. And diagnostic analytic, we try to find out why. Okay, if we use that data warehouse, which already organized our data using measure, and which is facts table and dimension table with dimension, and potentially just using pivot table, we can kind of know why our sales go up. Maybe you find out one product sales just shot up in the last 2-3 months. That is diagnostic analytic to answer why, which is not an easy job, but we're getting there. Predict analytic, we use machine learning model, we use statistics, we're using forecasting model. We're just asking what would happen, okay, looking at the future. Last is prescriptive analytic. This is the traditional operational research. We use optimization model, simulation, and management science to help us to determine what you should do under certain constraint. How can you optimize or maximize or minimize, let's say, maximize your profit. Okay. And data analytic has a life cycle that we follow and go when we need to analyze the data to answer an important business question, to find pattern or insight in the data to inform decision making. So let's look at here. I have kind of a web page. If you click the link or follow the link, you would come to this web page. I'm using Cloud.ai, which generates this for me based on the information that I submitted. Okay. 5 stage, ask a good question. Okay, what's the problem? What's the opportunity? Collect. Okay, gathering data. We talk about data gathering. Clean, data preparation. Clean up the data, format it in a format that may be easier for us to feed it into, say, machine learning model. Okay, and the fourth is analyze. Okay, analyze the data that has been cleaned up, okay? And hopefully we can gain insight, and that insight would help us to make an informed decision to act upon what we have found. Okay. So let's take a quick look. Ask. Okay. Define a clear and very specific question that you would like to ask. Understand your business goal or objective. Identify or define a set of criteria, which is how you will use to measure the success or not of your project. Okay, and determine what insight may be needed, and eventually set the proper scope and timeline for your project. So that's the first phase of the data analytic life cycle. The second phase, gathering data from different places, including certainly our database, API call to some data source, gathering data online, flat file, customer survey. So data came from different systems. You do want to make sure that you collect all the necessary data, and the data are available for the data analyst to use, and clean up. Okay, prepare the data. Any missing data, any outlier, sometimes we may need to remove it. Okay, and we would normalize or standardize the data, which may make it easier for the downstream analytical work. Any duplication. If there is duplication, we want to remove the duplicated record. Transform is to organize and shape the data and transform some of the data element such that it's ready to be used by the analytical model. This is the core of the analytical life cycle phase, where the pattern and the insight in the data may be obtained. Okay. And you can initially conduct so-called exploratory data analysis, EDA, and do some statistic analysis, hypothesis testing, use data visualization to help you to see some pattern, which will be easier for human analysts and also easier for manager to understand, and eventually generate actionable insight. Act. Okay, act upon insight that obtained, and we, as an analyst, you do present your finding and do a little storytelling through your data, and make implementation recommendation to the manager. But eventually, it's the manager make the final decision. So this is our data analytic life cycle: ask, collect, claim, analyze, and then act. There's definitely feedback loop among this various phases. So let's come back to slide. I have just one more slide to wrap up. Okay, we were here earlier. So to summarize, if you look at the key points here, is when you engage in a data analytical project, you do want to have a clear goal and make sure you understand who are the stakeholder who has stake in it, and where can you find the data that you needed, and what's the quality of the data. And you do want to uncover insight and present that clearly to your sponsor. You want to connect the data and your analysis to the decision making from the business side. Make sure you surface your assumption and then you validate your assumption. So last, this is just a list of, I call it, analyst go-to question based on what we have discussed so far. Like, what is the goal of this analysis? Okay. Learn to ask the right question. Okay. And second, okay, who will use this insight? That's kind of stakeholder, understand your stakeholder. What data source are available? Where you get your data? Okay. Is data reliable and clean? If not, you may need to clean it up yourself. Okay. What trend pattern normally can we detect? Okay. We'll get into analysis and how can we visualize it? Okay. And what decision will this data or data visualization that we presented will be influenced by such analysis? Okay. And are we making certain assumption when we make certain recommendation or analysis? Are those assumptions a valid one? And then what action can we take based on our finding? Okay. It's more, we have to think not only about the data, not only about the decision, but also the action that's the result of decision making. Okay. And how we measure the success or failure of the this analytic initiative. Okay. What's the impact? So that's it. You will be hearing a lot on data analytics, business analytics, decision science, or broadly machine learning, which all try to help manager in business to use the data they have collected, stored in the database, sometimes in the flat file, in the data warehouse, to get most out of it. Okay, that's it. Thank you for your patience, and hopefully I have a chance to see you online again. Bye-bye.